All right, welcome to technical session number 43. Getting kind of high up there on our numbers. Where this session, we're going to be talking about different types of user access. So we're going to be getting a little bit more into the different types of users. We're going to be talking a little bit more about the NTFS or New Technology File System and how it addresses threats. We're going to be comparing and contrast various NTFS directory and file permissions. So this will be a bit of a review on that. And then we'll talk about single sign-on and BitLocker and encrypted file systems as well. All right. Behavior skills and mindsets to keep in mind for this particular technical session are adaptability. As the industry continuously changes, so shall we, and personal responsibility. If we say we're going to do something, we do it, and we take accountability for our actions, both the bad and the good. Always such a negative connotation with responsibility. You know, it's like, well, yeah, I did that, instead of, yeah, I did that. So, Windows, it's a Southern thing. Windows user accounts and groups. So a group is kind of like a container that holds multiple users within that particular grouping, and it would establish the rules, capabilities, and accessibility of its members. So they tend to be a pretty efficient way of managing multiple users at one time. So we would have like the administrative group, we would have the HR group, we would have the accounting group, we would have the operations group, the C-suite group, all of those people, and then they would have various levels of access and authority throughout the systems. So 4 main types that we would see in Windows is you have your administrators, power users, standard users, and guests, which we don't have to worry about because we as good administrators already went in and disabled those accounts. So, administrator group, privileges. They have the power to perform the smallest tasks all the way up to removing the operating system, and they are the most powerful of all users. Who should have this? These should be for your system admin group, and basically limited to them for the most part. And also to try to prevent or to protect against doing mistakes, the practice of logging in with administrator account only when you need it. Because 99.99999% of all tasks that we need to accomplish can be done with a standard user account. So we have our standard and our administrators. Power users. This group would typically have read-write permission on the system and allowing them to install most types of software, but keeping them from changing key operating system files. This is typically for software developers, people who are testing software, junior administrators, and probably, yeah, your frontline IT personnel would have this level of access. That's your power user group. So it's like a standard user plus. Standard users, they have read-write permission to their own profile. They cannot modify anything system-wide. They cannot affect registry settings or access critical system files. And basically, this is the vast majority of the people on the network. Operations, accounting, HR, all that would typically have this type of account. And then finally, guests, same rights as users, except they can't get to log files. Who should have access? It says this account is created by default and is a member of the guest group. and we know they should have these disabled. So if we have guests coming in from other offices, like sales personnel or what have you, coming in and they need to use our network, we would typically have them established already on the domain, and they could use their domain login and be just fine. If we have sales professionals that come in and need network access, we may have a secondary network set up that is quarantined in the DMZ or something along those lines just for that purpose. So they would not have internal access, they would just be set up in a secondary network or separate network. All right, configure your users and groups. So every version of Windows has a group management tool. Most of them included, they're set in the control panel, and the applet in there is called user accounts. You can get to the settings, what access, what level of permissions do they have, all that kind of fun stuff. Can they access the control panel themselves? We can set up group policies. More advanced editions have the local users and groups, because you'd have your domain users and you have your local users on that individual machine. And that would be like on your enterprise and education level ones. How do we control what they are able to do? Through the UAC, or user account control. And this is intended to prevent unintentional or unauthorized changes to the computer by either requesting or requiring administrative access to continue. They may either request that permission from the administrator, like send a message to us saying, hey, such and such is trying to access these permissions, or it would require an administrator to log in at that time. Windows 7 had various levels of it. There are more advanced features, obviously, in Windows 10 and 11, which we are more concerned about. You can set it to always notify. Notify me only when the programs try to make changes to my PC, and notify me when the programs try to make changes to my computer, and do not dim my desktop, and then never notify it again. This is much like the firewall situation where people go into this and they're like, I want maximum security, and they put it all the way to the top, and then it bugs the heck out of them for about 5 to 30 minutes, and then they drop it down to nothing. Where we are going to be somewhere in the middle for the average users and the average companies, because we are trying to balance convenience and security. So we want to have good security, but we need the convenience to be able to do our jobs. So if it is extremely difficult to log in and extremely difficult to access things and all that fun stuff, it is going to slow us down and make us completely unproductive. So what companies have is they basically come forward and they say, we are willing to accept a certain amount of risk in order to have the convenience we need to do what we need to do on a daily basis. They call this risk appetite, which is the allowable risk that you are willing to accept in order to maintain the level of convenience you want. All right, parental controls. We talked about this a little bit earlier. We can set it up and it does content filtering. Anything above a particular age rating or something along those lines will not be allowed to come through. We can also monitor and limit their activities. Do you only want your child to have access for 30 minutes a day? Do you want internet to be cut off at a specific time, like when it be bedtime? Me, I'm a particularly cruel parent. I do not allow any screen time in my house except on weekends. And when it's on the weekend, they may have an hour a day, so long as their grades are maintained. The only exception to this rule is if it is directly school related. But we can establish these rules on anything that they touch. We can set it on TVs, anything that is connected to a network. We can establish it in a group and then establish what rules we wish to have on that group. So any device that my kids would touch, TV, computer, tablet, anything. No access during the week. and this is where we would set some of that stuff. We could also set it up in our router controls as well. All right, NTFS, or New Technology File System. This was the newest one, kind of replacing the FAT32, FAT64, because it offers a lot more security features and all that kind of fun stuff. It can handle the much larger disk sizes. And it allows you to create individual security for each of your directories, files, volumes, or what have you. It views individual files and folders as objects, and so it makes it easier for us to apply security to those individual pieces. Also, bear in mind, it is possible to convert from FAT32 to NTFS without losing your data, but we cannot do this in the other direction. Is there a lab for this? Yes. Hopefully we've already completed it. So I think it was assigned like 2 weeks ago, 3 weeks ago. All right. Here we go. NTFS security, getting into this a little bit more. We're going to be talking about permissions, file permissions, directory permissions, single sign-on, BitLocker, and the all wonderful EFS. So first, permissions. So we have share permissions that apply only when the user is accessing a file folder through the network. So this would not necessarily be on your local computer. These are network-based permissions. Then we have local permissions, which would be on that individual computer, and they would be used to protect individual files when the user is local. So say I sign out and then my son signs in. I don't want him having access to my teaching material, to my accounts or any of that fun stuff, because what kid would not like to have the sign in password to their parents' Amazon account and then just start going crazy ordering stuff. So we can lock local permissions and stuff like that as well. NTFS permissions are able to protect at the specific file level, while share permissions can be applied directly to the directory level only. All right. So within NTFS permissions, we basically have 3 options, which is allow, not allow, and deny. And we'll talk about these in a little bit more detail. And then we have what are called inherited and cumulative applications of permissions. So inherited means if I apply all of this stuff to a directory or a folder, all the permissions that I apply to that folder are going to pass down through every file and subfolder within that group. So everything below that aspect of the tree has all of those permissions inherited to it. Then we have what are called cumulative. So if a user is a member of one group and that one group has the read permission, and then they're also a member of another group that has the write permission, they would essentially stack, and that individual user would have read and write permissions on that file because they're a member of 2 different groups. All right, this is something you definitely need to know. The difference between copying a file and moving a file. So if I copy a file, it will have the same permissions assigned to it as if it was a newly created file in that folder. So if I copy from my drive to the administrative drive for the school, so I copy a file from mine to there, it would have the same read-write permissions as the file that I wrote it to, that I've copied it to. If I move the file, however, it will maintain the read-write execute permissions from the original folder. So copying it, it takes on the attributes of the new folder. If I move the file, it retains the permissions of the original folder. Write it down, highlight it, exclamation points, put arrows to it, put it on your pillow.
What do you mean by it retains the original permission? I mean the permission of the original folder.
So if I have in that folder that I am able to read, write, and execute, but Rachel's only allowed to read. She cannot do anything else to that file. So that's on my drive. On the corporate drive, we both have read, write, and execute permissions. If I copy to the new folder, if I copy it to the new drive, then both Rachel and I will have read, write, and execute, because that's the permissions of that file or that folder. If I move the file from mine to the administrative folder, then I would still have read, write, execute, but Rachel would only have read capabilities because it retains the permissions of the original file or original folder.
Okay, that makes sense.
Okay, so that's the difference between copying and moving a file in the NTFS file system. So please, please know this. It will come up repeatedly.
When I think about it, I think about how move is like, move is, it remains the mother.
Okay.
Copy, it becomes the children, which inherits.
Okay, that's what we'll look at. It's so weird hearing through a microphone, because like if the microphone is like 10 feet away from you, what's to the right of the microphone is not necessarily to the right of me. And so like it's like a distorted perception. Excuse me. I have like weird sounds happening and I'm like looking over here, but it's like happening. All right. We all got this? All right. So file permissions. I believe we already saw this one before, but this is definitely one we're going to want to look at again. Take a screenshot of this. Here are the different file permissions that we can have with regards to the NTFS. So you have full control. User has permission to take ownership, change the permission, do whatever they want, read, write, execute. They can change who's the owner, all that kind of fun stuff. That is full control. Then you have read, which allows the user to view the contents of the file and see the ownership attributes. So basically they're able to read the document and see who's responsible for that document, who owns it. Read and execute. It allows you to execute from the file. So say you have a file with some Python script in it, you can execute that script from the file if you have this permission. If you don't, you can only read the code. Write ability allows you to overwrite the file, change the attributes, and see the ownership and permissions. And then modify combines read and execute permissions with the write permission, but it also allows you to delete the file if you so choose. So that's full control, read, execute, write, and modify. You need to know this. Questions, comments? And I would distinctively put it under the header of file permissions. Why do I say that? Because we need to Here's what it looks like in Windows. So you would check off, if you were the file owner, what people or groups would have access, what access they would have. And then you have directory permissions, which are a little bit different. So directory permissions, full control, much like full control of the file. User has permission to take ownership, change who the owner is of the directory, add, change any of its contents, and change any of the permissions. So they can do whatever they want with it. That's full control. Read allows you to navigate the entire directory structure, go into its subcategories, subfolders, all that stuff, view the contents, view any files in the directory and read them if you wish. You will also be able to see who has ownership of the files and their attributes. Read and execute, same as read, but it also allows you the ability to run executables. So again, if there is like Python script in some of the files, like you have programs essentially set up that way, you could be able to execute and run those files if you wish. Write ability allows you to overwrite, create new entities within the folder, as well as change attributes of files in the directory. List folder is probably the least of the permissions. This just allows somebody to basically go through, look at the contents of the directory and navigate subdirectories and see the titles of things, but they will not be able to go into the actual files themselves. So this is slightly lower than read capability. And lastly, we have modify, combines read and execute, much like the file permissions, with the right permission, and allows them to delete everything if they so choose. Those are your directory permissions. Please make note of these, take a screenshot, pictures, hang it on your wall. Directory permission selfie.
So I think only the list folder is the addition in the directory permission. The rest all is the same, like the file.
It's all, yeah, but it applies to the directory level versus a file level. So yes, you're correct. All right, this is kind of what the directory permissions look like. It's very similar to the file permissions. You would set up your group or individuals you wish to have access, and then you could individually go through and select what access they should have. I believe we've already done labs on this in both Test Out and Coursera at this point. But always good to review. Ravensley, check your vents for debris on your device and or don't have it on your lap or a towel. Also, are your fans turning on? Let's see here. All right, single sign-on. Used to prevent password fatigue, because we have, at many organizations, dozens of systems that we need to sign into based upon our job functions, and creating new and unique and fantastical passwords for every single one of these systems can be a bit much for us to remember. So what some organizations have used, they start utilizing a single sign-on with an authentication server. to basically allow users to have access to everything that they're supposed to have access to. One of the more popular ones used is an authentication server called Kerberos, which provides ticket granting tickets. And it basically, you know, once you sign in, you're given these tickets. These tickets are being used when you log into or you go to other systems that you need access to and says, hey, I've already been authenticated. You can let me in now. Other ones, Microsoft Active Directory, Novell eDirectory, and some just utilize certificates. Benefits, password fatigue, helps retain security through the use of complex passwords for individual systems. Awesome. Saves time re-entering authentication data. Awesome. Saves time for IT, not having to reset passwords. Awesome. All good stuff. Big negative is if somebody gets access to that single sign-on, they now have access to everything you do. So, some good things, also some bad. BitLocker, we bring this one up quite a bit. Full drive encryption tied to the TPS mechanism on your motherboard, which is good because if our drive is stolen and attached to another computer, it will not boot. If any of the system files are altered, it can lock the drive to a particular machine, meaning nobody else can open it and they don't have your motherboard, preventing this theft of the particular hard drive. BitLocker to Go kind of works like this, but it operates on removable hard drives and thumb drives and things of that nature. And this is a good way to kind of help prevent unauthorized access to individual files on your removable drive. Now, full drive encryption, super awesome. Big negative, majorly processor heavy, because everything needs to be encrypted and decrypted on a regular basis, slowing down everything. So bear this in mind when you utilize BitLocker. It is going to slow down average operations just because of the processor heavy function of encryption and decryption. Now, if we don't need whole drive encryption, and we just want to encrypt the sensitive stuff, like, you know, I don't necessarily want to encrypt my Candy Crush files. I want to, you know, share those loud and proud. High score of 200 last week. We can utilize the EFS or encrypting file system, which allows us to encrypt individual files or folders, taking a lot of the processing burden out of utilizing the average files in the system and adding security where it's needed to individual files and folders. And just a gentle reminder, there have been many legal cases that have been litigated in the last few years that basically state if you take no actions to encrypt your data or your transmissions, then there is no assumed right to privacy. All they have to do is go to your internet service provider and say, hey, please give us Kelly's records. And they say, happily, here you go. But if encryption is being used, then more legal scrutiny is required.
Sorry, quick question, Mr. Kelly, going back to EFS. So what if I copied an encrypted file to an exFAT thumb drive, and then I use it in a Linux machine?
You would have to, one, you would have to have the authorization to decrypt it. And if you do, and then you transfer it to an exFAT, remember you're taking on the properties of the new folder. So you would not have the permissions and encryption levels of the original system. And then it would be up to your Linux system to determine the encryption level.
So if I have it on a thumb drive that's formatted as FAT64, and I plug that into a Linux machine, the encryption will still be on the file.
If you're using the encryption with regards to like a BitLocker to go or something like that, you would still need the key access to be able to get to it. But if you're just copying the file without decrypting it, you won't be able to read the file.
Okay.
So you would have to have the authorization to be able to decrypt the file and then copy it and move it, and then you would be able to read it on the FAT64 or an exFAT drive.
Thank you.
But yeah, if you just copy a encrypted file, you're going to get gibberish. All right. Windows 7, 8 stuff we don't need. Yep, over this stuff. Quiz time. That we should be able to define certain types of user accounts. So we have the administrative user, power user, standard user, guest user, which we have all diligently gone in and deactivated. Describe the NTFS file system and how it intends to address certain security issues. Compare and contrast various directory and file permissions, like read, write, execute, modify, full control in the directory list file. And then describe single sign-on, BitLocker, and EFS. Questions, comments, concerns, complaints, revelation. All right.